Suricata, wrong page. Suricata is a popular IDS, IPS software. It's free, it's widely used. Naturally, when we talk about Ubiquiti's IDS, IPS implementation, let's check whether it's using Suricata or not. This is my lab environment. I use a EFG as the gateway. What we discuss in this video is not about any specific UniFi gateway. So no matter what models you use, IDS, IPS works in the same way. So in UniFi Network Controller, if I go to Settings, for Security, go to Protection, you can see I already enabled intrusion prevention and applied it to all my VLANs. And for detection mode, I say Notify. I already selected all the available detection categories. So this is the simplest setting for IDS and IPS. In the lower part of the screen, I have a client, but let me first SSH to the gateway. Then let me launch top command to make it refresh more frequently. Let me set it to half a second. Okay, at this moment, the gateway is working in a very light mode. Nothing's happening. Then in the left side client, let me run this command. I already launched a ipv3 server at this IP address, which is in the WAN part. This client is in the LAN part. Let me run a simple ipv3 testing. Then see what's the change in right side. What's the top one process is Suricata main. So this already confirms, yes, UniFi Gateway does use Suricata to support IDS and IPS. Let me kill it. So now we have a good starting point because we are confident as long as we look into how Suricata works within UniFi Gateway, we will understand how IDS IPS works. This video will have 3 parts. First, let's talk about how Suricata is integrated with the gateway, how it can even inspect your network packets, do detection. Then the second part, we will look into the rules, where they come from, how they work, how they are categorized. Then the last part, we will see IDS and IPS work in action. Okay, let's get started. People tend to think IDS and IPS are almost the same. The only difference is IPS will prevent the intrusion, will drop the packet, right? But from backend, from technical perspective, IDS and IPS work in a very different way. For IPS, the system can work in a very active way. It requires Suricata to actively process and decide whether to drop or allow a given packet. But for IDS, it's more passive way, which means Suricata will listen, will log, will alert, but it will not alter the packet. So because of this technical difference, when it comes to how make Suricata integrate with the gateway or integrate with Linux operating system, it leads to totally different technical approaches. It's possible you heard of iptables, which is used by UniFi Gateway to do a lot of things. For example, firewalls, for example, net rules. Because now we are talking about to decide whether to drop a packet or not. Of course, naturally, we think of iptables, and Suricata does work with iptables, and in fact it's the recommended way because it's fast, it's closely integrated with iptables. Let's see whether it works in that way for UniFi Gateway. So let me first check filter table. If for UniFi Gateway it does use iptables to integrate with Suricata, it will use NFQ to support IPS. Let me check whether we have this target used. No. Then let me check another table. It's Mango table. No. And let's see if it uses iptables to support IDS in passive mode. It should use PCAP or AF packet. No. Okay, so I tried all the required targets. If UniFi Gateway does use iptables to support Suricata, but it turns out no, which means Ubiquiti doesn't choose the inline mode to support Suricata's IPS functionality. And it also doesn't use the passive mode to support IDS. You know what? That makes sense because some people may choose IDS only. Some people may use IDS in the beginning. Once they are comfortable, they will switch to IPS. Right? But to support IDS, Suricata won't work in a very efficient way if you integrate it with iptables. However, we cannot draw the conclusion that Ubiquiti's IDS IPS implementation has nothing to do with iptables. The reason is what we checked is based on IDS, the detection only. But you can see now in network controller, I already changed the setting to notify and block, which means it's IPS, right? Think about it. If you want to block the traffic, the system has to do something in iptables. Otherwise, how you can drop a packet, right? After enable the IPS instead of just IDS, I expect to see some changes. So now let me run iptables again, show the filter table. Then let's see whether we can find more information. Okay, see, I can see the change. For example, for forward, the very first subchain is IPS. This IPS subchain reveals all the secrets. See, the target is called IPS, log, and drop. So this is not a standard Linux iptable target. I assume this is a Ubiquiti's proprietary implementation about a target just to log and drop a packet based on IPS. Then let's see based on what it will drop the packet. It's using a IP set. It's called IPS, and here there's a very interesting syntax. You have 3 values, DST, DST, SRC. It looks very confusing, right? But if you quit this iptable, let me show you the IP set. The name is IPS. So even though now there's no any value in the IP set, but here it explains the structure. Basically, it's a tuple of 3 elements. So the way to read it is the first element is the destination IP address. The second element is the destination port. And the third element is the source IP address. Of course, in the iptables, in the IPS subchain, there's a second rule which match the source IP, source port, and the destination IP in a similar way. Okay, but because everything happens so fast, I cannot show you the IP set works in real world. This is how I understand it. So the system will dynamically manipulate this IP set so that the iptables will know whether to drop a packet. Okay, this is just for IPS, right? But to really understand the majority of the integration between Suricata and gateway, we need to change the detection mode back to notify so that we will understand the majority of the flow, how the system works. Let's see whether the UniFi gateway uses different approaches to integrate with Suricata. Let's continue looking. Let me use PS to show the current process list. Let's see whether we can see Suricata there. Yes, this is what we want to find. Just from this command line, we can tell a lot of information to understand how Suricata works in UniFi gateway. So first, let's see this one. This is a super important parameter. Remember, we just excluded the possibility that iptables is used, right? And this parameter tells us Suricata is using pcap to integrate with gateway. Pcap stands for packet capture. Pcap here can mean 2 possible approaches. First approach is like offline mode. Only when needed, you run this command. It will capture the packets to a file. Then you can inspect the file offline. But apparently, it's not the way how UniFi gateway works because we see the real-time detection and the prevention, right? Which means Suricata is capturing packets in a live mode. So to confirm that's really the case, we can check 2 things. So first, let me see the netstat command. So let me run netstat command to see whether we can see any information about Suricata. Yes, Suricata is listening using a Unix socket. This is the exact second approach I just mentioned. You capture the file in a live mode. This result confirms it is using the Unix socket to listen on a stream. And to furtherly confirm that, we can run a command suricata sc. Then we can show the capture mode. Okay, see, this is the result in JSON format. Tells us yes, the capture mode is pcap dev. This capture mode means Suricata is capturing packets from a live network interface. It will use a Linux library which comes with TCP dump. It's called libpcap. It will use this library to grab packets from given network interface. As shown in this blue link, Suricata use libpcap to grab packets from given interfaces. libpcap library is generally slower than the other modes like the AF packet or NFQ in iptables due to user space processing overhead. But that's how Ubiquiti decides to integrate with Suricata. And the libpcap will grab from what interfaces? From network controller, you can see we set these 3 networks, right? Let's go to the backend to see whether Suricata do the live capturing against these 3 interfaces. To find out the Suricata's configuration, we can continue looking into this command line. See here the -c, which means the configuration file, and the configuration is within this folder. Let me copy it, cd to that folder. Let's look at this one. Suricata ubios hi. It's a YAML file. Let me vi it. See this section, Unix command is set to alter, which confirms it is using Unix socket to listen to the captured packets. Then at the end, it included another YAML file. It's about interface. Let's look into this file to see what interfaces the Suricata is actively grabbing packets. Exit this file for now. Then let me vi the interface configuration. Okay, we see BR0, BR88, BR10. What they are? They are exactly the 3 networks we configured on the UI. So now it explains this part. So we are completely cleared how Suricata get the packets to do further analysis. It's using libpcap to grab the captured packets from these 3 interfaces, and it's using the Unix socket to listen to the captured packets. Okay, now we are good with this blue link part. Let's go to the second section of the video. Let's focus on these red links, which are about IDS, IPS rules. We just look into this config folder, right? It contains the IPS, IDS configuration files. If we cd to its parent, you can see there is a rules folder. There are tons of files with the suffix UI_rules. They are the IDS, IPS rules used by Ubiquiti in its gateways. Because in this terminal environment, it's not very convenient to look into the content of this rules file. So I have copied them to my local machine. So let me open the folder in my local machine. There are 2 folders, config and rules. In the config folder, if I open this JSON file, category list, you can see some interesting information. It has 2 big sections. One is called open, the second is called pro. In fact, the open corresponds to your default IDS, IPS categories, which you can see when you set up IDS, IPS. If you count the numbers of the files in the config and the number here, they match. They are called open, which means they are free. Then the second category is called Pro. It has 50 some files. I assume they correspond to the paid version, which is cyber secure. But because I haven't subscribed CyberSecure, I'm not 100% confident. This is just my assumption. If you check the left side Ubiquiti's help regarding CyberSecure, it does give some counts regarding the categories for different UniFi gateway models. For my case, EFG, for the paid version, it has 53 categories. If you count the Pro rules, they match. And another interesting thing is for the non-enterprise version, for example, for your UDM Pro, there's a breakdown by regular category counts and so-called memory optimized mode. I don't see explanation about what's memory optimized mode, but they happen to match the free version count. Of course, I'm not sure whether they are the same thing or not. Another observation is for everything which is in open section, they are also in Pro section, which means even though here in documents it tells you, okay, if you pay for CyberSecure, you will have 53 categories. It doesn't mean all of them are brand new because you already have 30 plus categories in the free version, which is also included in the paid Pro version. Okay, then if we go to the rules folder, here it lists all the 50 plus open and the Pro versions. So for example, let me pick DNS category. There should be a file named as DNS rules. Here is the DNS rules file. It is the free offer. Let's look at the comments. It tells you one important information where the rules come from. All the rules file in your UniFi gateway, they come from emerging threads. Let's look at the diagram to understand the relationships among all the components. So you have a UniFi gateway. It doesn't have its own proprietary IPS, IDS. Instead, it uses Suricata directly. But Suricata is just a rules engine. It's an engine. It doesn't come with rules. Then to do real-world IPS, IDS, you have to have rules. Then those rules are provided by emerging threads, and in many places it's simply referred as ET. So all the ET rules are provided by third party. Suricata simply use them during runtime. This is engine, this is rules. What's emerging threads? They are rules maintained by proof point. It doesn't matter whether the rule is open, which means free, or pro, which means you need to pay for it. They are all maintained by proof point. That's why when you pay your so-called CyberSecure for your UniFi gateway, you are paying proof point. Your UniFi gateway will routinely download the new updates from proof point. What it will download? It will download the changed ET rules, the emerging threat rules. Everything we see under the rules folder, or the 50-some files, they are ET rules. Having cleared that away, let's look at some example rules. So I pick DNS rule because it's the simplest one. Let me pick a random one as example. For example, this one. Alert means it is a rule, doesn't mean it only supports IDS. In fact, for IPS, it's the same rule, right? Then here you can see the protocol, and then you see the direction. It's from what to what. So for this rule, it only applies when internet trying to reach out to your home network. This may clear some confusions among many people. They take it for granted IDS, IPS means from your LAN to WAN. No, you already see this example. It's from WAN to LAN. Right? I can also show you other direction, for example, from LAN to LAN. So let me search for home net to home net. See, so many rules are listed out. Let me click on a random one. So here, this one is for malware and is from your LAN to your LAN and to this particular two ports. The reason I want to show you this is IDS and IPS applies to all sorts of traffic, not just from LAN to WAN, which means the limitations or bottleneck you see in all the specifications or documentations regarding UniFi gateway about IDS and IPS, they not only apply to your internet traffic, but also apply to your inter-VLAN traffic. Okay, let's go back to the DNS example. And then here you see the part. This part is just the description of this rule, and follow that. That's a real logic, if you will. So basically it says the packet has to have this content. They are in hexadecimal format, so your packet has to have this content. And then there are many ways to specify the rule. So for details, you may want to refer to this document from Suricata. It's about rules format. And then let's just pick some random other ones. For example, DOS, denial of service. For example, this random one, the protocol has to be HTTP and is from one to your own HTTP servers, and the flow has to be established. It has a count. It has to be 100. Then within how long, and then in the content it has to have this string. A lot of different ways to specify the pattern or the signature of the packet in a very detailed way. In the interest of time, in this video, we will not look into the details of how the rules are defined. So you can see, depending on what type of rule, for some, they can be very simple, but for the other, they tend to be very complicated. A lot of things need to be checked during runtime, and for IDS, IPS, it's not offloaded to hardware. It has to be done by CPU, by software. That's why IDS, IPS is the biggest bottleneck when it comes to your gateway's throughput in many cases. Even you only talk about the free version, we are talking about dozens of thousands of rules. Before ending this video, let me show you several examples about IDS, IPS works in action. Let me first choose a easiest one, a DNS intrusion. This rule looks very simple. The only requirement is if your DNS query contains this domain name. So we can easily simulate it from a client. Let me run dig command. Okay, it's done. Then in the UniFi network controller, let me go to system log. Under threads, you can see all the detection logs. So see the very latest one, a network intrusion from this Debian machine. The IP address is .1.23. Then in lower part, let me confirm. Yes, it is this client's IP address. And then see what's the details of the intrusion. It's ET DNS query. And if you go back to the rule, you can see it's the exact same rule. So we successfully simulated this intrusion, right? Then let's try another example. For example, this one in games rule. It has to be TCP. It has to be from LAN to WAN, and the WAN part has to be 6112, and the content has to include this hexadecimal values. So we can simulate that by using NC tool. NC is a very popular network testing tool. To simulate a server in the WAN part, let me run NC command, listening at port 6112, which is required by that intrusion. Then from the LAN part, let me run NC command as well. So basically first I will construct a binary string. This is the pattern, the content mentioned in the instruction rule. Then I will use NC to send it against this server's IP address and the port 6112. Okay, then let me run it. See, in the left side, the server successfully received the packet, right? If we go to the threads log, after refreshing the display, I can see the new threads logs generated by IDS IPS. It's from this lower part, Mac Mini M2 Pro. Then let's see view in flows. Let's see the details. See, the signature is exactly the one we were simulating. And if you want, you can go to the advanced information. You can see more details. Okay. one thing I want to mention is don't expect the logs to appear right away in real time. You need to wait for some time. The system doesn't really refresh the logs very frequently. But if you want, you can SSH to the gateway and then cd to var log ulog folder. Then here you can see two files. The first one is the syslog. The second one is for the threat detection. If you display it, yeah, you can see all the logs which are displayed in the UI under threads. But the file is updated pretty fast, much faster than the UI. Okay, this ends the video for IDS IPS in UniFi Gateway. Thanks for watching.